Welcome back to the channel. In today's video, we're going to continue on our fundamentals of analytical chemistry video, where we focus now on the data visualization. Over the past few videos, we've done things like exploratory data analysis, hypothesis testing with t-test and ANOVA, and now I want to show how we can take some of these same sorts of tools with Python and do some visualization of multidimensional data sets that don't require statistics. In this data, we are looking at the soil fertility and comparing that between two different farms. And so we've shown that there are differences based on the t-test and ANOVA tests. And now I want to show how we can come to those same conclusions with data visualization and the parallel coordinate plot specifically. So here we have our data set, and in this field column, we have multiple rows of field 1 and field 2, and several different soil measurements related to pH, clay composition, organic matter, and many others. The link to the actual study will be in the description below, so check that out if you want more information. And now we're going to work on visualizing this data to see if we can come to the same conclusions we came to using the t-test and ANOVA. So here we have a data set where we have multiple different variables, and we may want to look at all these variables together in a way that we can see all the dimensionality in sort of a flat line. So to do this, we will import plotly express as px being the alias, and then use the parallel coordinate plots method. We will use parallel coordinates, and inside we will pass in our data frame, which will be viz.df. And if we run this without any extra input, you see out of the box it does a pretty good job of visualizing the data. Although there are some features that are missing, we have flexibility with the order of the columns that we can prescribe. One of the nice things about this plot is that we also have a way to dynamically filter the visualization. However, it's really difficult to see the impact of field 1 versus field 2 without some other metric for the color. So to do that, let's pass in a color argument, and we will set color equal to the column called field. And for visualization purposes, it can be kind of difficult to see the yellow versus the blue, so let's also update the color map. And for the sake of this video, it's much easier to see the two colors when we use the tropic color map, but there are several options you can enjoy just by checking out the Plotly documentation. So here we can see that now it's pretty clear that field 1 and field 2 have different chemical patterns as a function of the location, and we can slide this filter here to see those differences. If you want to understand it with a little bit more nuance, we can choose one of these other areas and filter there. And we can even combine multiple different filters on the different parallel axes. So this is a great way to look at wide data sets in a linear fashion, and a method that translates really well when talking to other stakeholders outside of the field. So with parallel coordinates, one of the limitations is that you have to plot numerical data. However, there is an alternative called parallel categories, where we can now plot categorical data, and in some ways may actually simplify this visualization. And so in the next video, I'll show you how we can convert all this data to categorical data, and I think visualize this in a much simpler way for stakeholders who don't want to see all of these lines, and it will be up to you to figure out which approach you think is better for the different scenarios. If you enjoyed the video, like, comment, subscribe, and I'll see you in the next one. Peace.